Hello, I'm Giginet. Do you know Mahjong? Everybody plays this game in Japan. Mahjong has been played since ancient times all around the world and now online, even on the Swift compiler. Today, let's implement complex logic like Mahjong's winning hand detection using Swift type system. Our goal is to achieve the following compilation time compilation on the compiler. I'm sure you are all familiar with the rules of Mahjong, but don't worry, I'll review them anyway. Mahjong is a game in which you arrange 14 tiles. You collect one head of 2 tiles and 4 melts of 3 times each. When these 5 groups are complete, it's a winning hand. There are 2 types of melts, identical melts and sequential melts. Let's try to represent this complex state using the type system. For simplicity, let's define a hand type that takes 5 type parameters, head and melt 1 to 4. Head and melts are representable in structs. First, let's define the tile type to construct melts. Imagine a Mahjong tile. If you look closely, you can see generics. Sorry. The feature introduced in Swift 6.2 for this purpose is integer generic parameters. My first idea is that using IGP can represent hand states in the type system. First, let's detect the identical melt. Here we write a same value constraint using IGP. Let's try in playground. Now we can determine whether identical melt is a valid melt. Similarly, let's consider sequential melts. If we try to write sequential group constraints like this. Oops, unfortunately, this doesn't work because arithmetic operations are not supported in IGP yet. The current Swift type system cannot express sequentials using int types. Swift evolution mentions this will be supported in future versions, so we need to find another approach. We need to create our own type that represents sequences. By defining numeric types with the next relationship, we can simulate sequential numbers. Let's detect sequential melts. It works. When we add win protocol conformance to the hand type, look, only hands with valid melts become valid wins. However, valid melts need to cover both identical and sequential states. This is similar to the concept of union types in other languages. Let's try to define multiple conditional conformance to express the union type. Oh, we get an error. Unfortunately, Swift's type system cannot conform to a single protocol under multiple conditions. In other words, union types cannot be expressed. So Swift time system cannot perform complex numeric computation or express union types like sets. In short, winning hand detection seems impossible with the pure type system alone. So can we play Mahjong with the Swift compiler? Let's use expression macros. With macros, we can do complex tasks using only compile time computation. First, we can pass 14 tiles directly for the macro. Using inline array guarantees tile counts at the type level. Additionally, we can also check for any specific winning patterns. With the macro version, it can group hand into methods automatically. Also, it can detect winning patterns, not only detecting winning or not. Conclusion. Swift macro is the silver bullet to represent complex logic in the compilation time. What's the practical use, you ask? Well, it was useful for looking back the new features of the recent Swift. Mahjong can be played anywhere. Thank you for listening.